So the Arctic sea ice loss is making a lot of news, and it's almost like one of the key features to watch in terms of the global warming impacts and what could be a regime shift because of warming. Would the summer ice in the Arctic completely disappear before our eyes in the coming years or decades? The other big debate, of course, is that there is a very clearly observed polar amplification or Arctic amplification that is related to ice albedo feedbacks and cloud and water vapor feedbacks, which are special to the Arctic atmospheric circulation as well. And the big debate has also been whether the Arctic warming and sea ice loss is creating a more wobbly jet stream, polar jet stream, and creating the more extreme winters in the US. This debate has been going on since almost a decade. The latest paper, in fact, came out just a week ago in Science by Judah Cohen and colleagues, which argue that, in fact, the sea ice loss does affect the stratospheric jet stream, the polar vortex, and that can then put down weather. And the US especially is got this kind of a central pathway pipeline to bring in cold Arctic air all the way down even to Texas. And this is the map showing the extreme cold associated with Arctic air mass, with the darkest blue region indicating surface temperatures of minus 35 degrees centigrade. This is from NASA and was reported in New Scientist as well. So if this is the case, and in fact there are big perturbations to the jet stream and surface pressure patterns over the high latitudes, can it also affect the Indian monsoon? And a nice little paper came out again just very recently in July, I think, from Saurav Chatterjee from the National Center for Polar Ocean Research and colleagues, which extends this idea. So here's the stratospheric vortex, which is not usually as wobbly as the polar jet stream. Polar jet stream is basically the referee between high pressure cold Arctic air and the lower pressure warm tropical mid-latitude air, and this can create Rossby waves and all sorts of wobbles, which can create warm winters over parts of Alaska, while at the same time creating cold winters over the central US region, and so on and so forth. The polar jet stream can send up momentum and energy and keep kicking the stratospheric polar vortex, which can then get angry and put down some weather, which is now argued to be related to the cold extreme winters over the US by Judah Cohen in the Science paper. Coming back to Saurav Chatterjee's paper, he looked at essentially the sea ice extent, most especially in the Kara Sea, which is sitting here in the northeastern Atlantic, and that is shown here with its decadal type variability and maybe being confounded by global warming in terms of the sea ice extent becoming less and less. And there is the associated latent and sensible heat fluxes, and here they are showing the differences between the lowest sea ice extent and larger sea ice extent. So there have been decades where the sea ice extent has been large or larger earlier in the century, and associated with that you have some variability in the All India summer monsoon. So Indian summer monsoon, which is shown here in terms of totals in millimeters per day, and maybe there is a correlation between them, but maybe now it's not correlated with each other anymore. So the question always remains whether the monsoon itself also has a decadal variability, and whether that decadal variability is being modulated by the global warming, as I've said many times. And if you look at the frequency of extreme events in August, September, they also have had this decadal variability. So there was lower when the sea ice extent was larger, is higher when the sea ice extent is lost, and then it goes low again as the sea ice extent recovers. And now both have gone in the same direction strongly, where the lowering of the sea ice extent, especially over Kara Sea, and the increasing late season extremes are highly correlated here in the post 1980 period or so, where we have the best data for the Arctic sea ice extent. This is some sort of a normalized September extreme events over the monsoon region. They do some normalization by taking the difference between low extremes and high extremes and then divide by something to make it normal. But mainly I want to point out that there have been decades with high September extreme events, and during the 1980s to about 2010 we have had high September extreme events as well, but you can see that there is a downturn in the late extremes here. But I will make another podcast on the late season droughts, which is another paper by Indian authors that is also presumably related to mid-latitude wave connection. So it's well known that the monsoon heating sends off Rossby waves which make it into the Arctic and may warm the Arctic and contribute to Arctic ice melt. But this is talking about the impact of Arctic sea ice loss, sea ice concentration and sea ice extent on the polar regions, which then propagate down into the Siberian high. So there are Rossby waves which can of course get stuck and propagate straight westward, but some of them propagate down south and then turn eastward, as you can see here. So we are looking here at average difference between years with increased and reduced extreme rainfall years in September. We are looking at 200 hectopascal geopotential height and wind vectors here. Okay, so the Rossby wave pattern is clearly seen. These anomalies are during August, September. So the idea is June, July, August ice loss, sea ice loss, is generating impacts on the atmosphere and sending it down into lower latitudes during August, September, okay, resulting in September extremes. B and C are the same as A, but for the zonal wind anomalies, which are seen here, and meridional wind anomalies. This is the average difference in anomalous meridional circulation over the 30 to 60 degree east longitude band between the years with increased and reduced extreme rainfall. So essentially it's talking about this zonal circulation which is related to these wave trains, and the explanation basically then relies on a upper level divergence created in August, September over the Indian region, which can drive a low level cyclonic circulation. But where does the moisture come from? Then they invoke the idea that the Arabian Sea has been warming since about the 1980s, and that is then able to supply additional moisture to feed the low level cyclonic circulation associated with the upper level divergence anomaly generated by this Arctic link. And that kind of Arabian Sea contribution to widespread extremes was also invoked in the Roxy Matthew Cole's paper, which argued that the widespread extremes have become much more frequent. They've gone from about 2 per year to 6 per year over the last 6 decades or so. So it seems like, at least tentatively, there is evidence that suggests that the Arctic sea ice loss and reduced sea ice concentrations are able to put down Rossby waves that can propagate southward and eastward, reach the Indian subcontinent in the late summer season, late monsoon season, and create upper level divergence anomalies which can drive lower level convergence or cyclonic anomalies which can then demand moisture from the Arabian Sea. Because of its warming, it is able to supply this moisture. Of course, we said even in the past, in the mid-1900s, when the sea ice extent was reduced because of natural variability, there seemed to be late season monsoon extremes as well. So was the moisture supply still coming from the Arabian Sea? Was the Arabian Sea warmer at the time, or was there some other region like the Bay of Bengal that was supplying the moisture instead? And so on have to be explored further, of course, and I'm sure people will follow up. So let's conclude this podcast with this summary diagram from Saurav. Sorry, I added this bit a little bit later. That's why you see it start again. But nonetheless, the idea is that the sea ice extent decline in the Kara Sea can drive changes in jet stream characteristics, the meridional migrations increasing that we have talked about, and also the anomalous meridional circulation that we looked at here. So we are looking at meridional, this is the zonal circulation, but you can see the implied meridional Rossby wave energy, Rossby wave activity flux here. This is averaged over 30 to 60 degree east, so this longitude band and looking at, yes, why am I saying zonal? Meridional circulation going from 50 north to the pole. So you can see this rising motion at high latitude and sinking motion over the 50 to 60 degree north, which is going to give us the associated coherent variability between the West European high and the East Asian high, creating these meridional zonal wind anomalies. So that's going to give us the enhanced blocking pattern in Northwest Europe, Rossby wave activity flux towards subtropical Asia, stronger subtropical high and upper level divergence. If you have upper level divergence demanding a lower level convergence, and if there is a moisture supply, obviously you can create extreme rainfall. And the moisture flux here is argued to come from the Arabian Sea because of positive SST anomalies there, which works obviously for this period. There is a warming over the Arabian Sea. It has to be confirmed for the earlier period where you had a similar link working with the Kara Sea ice being low in a natural variability mode, and the extremes being late season extremes being higher in the monsoon region. So that gives us surface cyclonic circulation, enhanced moisture convergence, and extreme rainfall. So there is a parallel story about North Atlantic wave flux creating a late season drought over India, and this is a key question which we will discuss in the next podcast from a paper by Venugopal and a company from CAOS of the Indian Institute of Science. Okay, so obviously if you have a Rossby wave flux that can create cyclonic circulation at the surface with the upper level divergence, then you can have the opposite phase which can create the opposite effect and droughts, and that's an interesting story as well that we will look at, okay, in the next podcast. Okay.